everyone. Thank you all for sticking around. I promise to be quick and interesting, hopefully. My name is Alon. I'm the CEO of SSV Labs. SSV Labs is the core team behind SSV Network, which is developing a based applications protocol. Based applications are a new way or a new type of decentralized application which actually harnesses and uses directly L1 blockchain validators for both functionality and security. We've been around for quite a while. We've launched 14 months ago and grew quite significantly throughout 2024. Today managing just over 2.1 million ETH at stake across 14,000 different mainnet operators, all on Ethereum, fourth largest staking protocol on Ethereum today. And I wanted really to tell you that there's a staking revolution happening in our industry. It might be silent, it might be kind of behind the scenes, but it's definitely there. When staking started for Ethereum back in 2020, responsibility for validators was really one thing, to secure Ethereum, and that's pretty much it. But almost as soon as Ethereum staking started and the genesis happened for the Beacon chain, MEV came along, and MEV is interesting both as a service, but also what it did for validators, which is it's an opt-in service that validators run optionally. They don't really have to run it, but most of them do. It's a service which is out of protocol, that it is not ingrained within Ethereum, but it is a service nonetheless for transaction ordering. And that was really the first type of service, the first type of responsibility outside of the kind of the base native responsibility that validator had. A couple of years went by, and we got introduced to shared security. At least in its original form, shared security wanted to reutilize Ethereum validators to bootstrap other protocols out there. And that was kind of the second category of services that validators could potentially opt into. Nowadays, it's not really that, but at least originally the idea was that. And now we're into the kind of the third type of category, which are validator commitments. It's a category which includes pre-confirmations, base sequencing, and a bunch of different other types of services. But the trend line is kind of obvious here. Validators are starting to do more and offer more than just being validators for a specific L1, in this case Ethereum. And that's really where based applications come along. Based applications harness Ethereum validators, but they harness the Ethereum validator entity. That is actually the entity that runs and actually performs duties on the Beacon chain. We use the validation keys for that. And that's quite interesting because the validator set of Ethereum is by far the largest validator set in the world. It's the most robust, it's the most diverse. And by tapping into that, we can create a lot of different use cases and bootstrap a lot of different use cases. And what differentiates those types of use cases is that they are based. They're based on L1 blockchain validators instead of, for example, restaking, which is capital driven, right? So by harnessing the actual validator, we can unlock a lot of different use cases from obviously pre-confirmations, base sequencing, all the way to data availability, AI agents, ZK provers, and the list goes on and on. All of them being able to bootstrap from actual L1 validators and harness the best validator sets in the world. And that's really what based applications are all about. But why stop with Ethereum validators? I mean, there's a lot of different other validator sets out there. And so within SSV developing based applications, from day one, we knew we wanted to be a multi-blockchain type of protocol. The idea is that we want to enable other L1s, Solana, Celestia, potentially even Bitcoin, Cosmos, all of those types of validator sets to bootstrap and extend their functionality and security to enable other protocols. By providing this coordination layer between multiple L1 validators and a bunch of different based applications. And that's really, really powerful because you can really create the most diverse and decentralized validator set in the world, create really economical benefits of competition between types of validator sets. And really, this is the first time anyone have ever tried it, coordinating multiple L1 validators to do things together instead of against one another. And that's quite remarkable. It's super interesting to bootstrap and enable that type of security across multiple based applications. And so that's multiple blockchains. But because we're using the actual validator, it's an untapped resource. Nobody's really using validators outside of their original scope, which is securing the specific L1. This untapped resource has completely different economics than capital, which is used in restaking. And as an effect, it has a completely different price point. Economically, based applications security is significantly different and significantly more affordable. And considering that security is by far the biggest expense of any protocol, from Ethereum to Bitcoin to whatever bridge, Oracle, AI agent you want to build, security is always the biggest expense. And so if you can create a security which is more diverse and more decentralized, more affordable, you can create more sustainable and much more robust applications. And that's quite interesting and super important, especially as we go into this world of shared security. The combination of the two, both scale, the types of validators, and their affordability, create this aha moment, I think, that is very similar to what happened with cloud compute and internet connectivity, right? Those types of services, the more their price dropped and became more affordable, the more users use them and the more use cases were built on top of them. And so if we look at shared security as something that needs to be kind of foundational to the future of blockchain, as we make it more affordable and secure, it needs to be enabling more use cases. And so with based applications, really kind of compared to the alternatives, we strongly believe that the combination of multi-blockchain validators together with this new untapped asset that nobody's really using right now can really create this aha moment where we're going to scale and create use cases which were not really available before that. And so how this whole thing kind of ties back to making Ethereum faster and more resilient and with better user experience. In my opinion, the most pressing challenge for Ethereum the next 12 to 24 months is synchronous composability. The idea or the dream that we can consolidate all L2s with a unified user experience, atomic transactions, potentially sub-second and potentially even sub-500 millisecond transaction confirmation. That type of user experience is something that Ethereum was looking for a very long time. But now we're kind of in a fragmented world, and this is becoming a really pressing issue. More so than any other things, but also in terms of value capturing. We want Ethereum validators to capture more and more value because they are by far the largest asset Ethereum has today. And so if this is one of the most pressing issues and challenges we have in Ethereum, I strongly believe that based applications can help improve and facilitate a lot of the solutions to that. This is how I think the tech stack for Ethereum in the next 12 to 24 months will look like. We have the validator set of Ethereum. That's by far the biggest validator set on Earth. And that gives way to the best data availability and settlement layer in the world, which is actually Ethereum, right? On top of that, we want to achieve a bunch of different things, with this big category called synchronous composability. But ultimately, we need an infrastructure component, a coordination layer to do that because it's an opt-in service, but it requires bond, it requires slashing, it requires coordination, it requires operators and validators and so on and so forth. And that's exactly what based applications are aiming to do. And so for me, based applications are this critical infrastructure, this critical coordination layer that will enable all of those types of things we want, from pre-confirmations all the way to base sequencing, maybe execution tickets, et cetera, et cetera. Not only that, if we kind of dive into that, it actually changes the economics of staking itself. And so if you're going back to saying validators are probably one of the biggest assets Ethereum has today, then validator economics are super important. And that changes completely the validator economics. Validators today earn base fees from Ethereum, transaction fees, ordering fees, and so on and so forth. Maybe in the next 12 months, they will start capturing a lot of the value from L2s, from preconfs and base sequencing. But imagine you can extend that much further than just those two things. And imagine you can extend that to any type of application. All of a sudden, you can harness not only the power of validators on Ethereum, but you can actually make the validator set of Ethereum better and more decentralized. And the reason why it becomes more decentralized is because we always talk about encouraging solo stakers, small-time stakers for decentralization's sake, right? The problem is it's not very economical. Mostly they are volunteering. But if we can change their economics and get them to earn much more rewards, imagine what happens if in programs like Lido CSM, Rocket Pool, EtherFi solo staker program, they can actually run validators on behalf of other protocols by posting a bond of, let's say, 2 to 4 ETH. Now they're earning, maybe covering their cost, maybe doing a bit more than that. But with based applications, they can actually earn much more. And all of a sudden, it becomes from a hobby, potentially to passive income, potentially to a small business. And so if we can increase what they earn, we can increase their numbers. We can have more solo stakers. We can have more small-time stakers. That ultimately benefits Ethereum, makes their validator set of Ethereum even better, more decentralized. And that's why this coordination layer for based application is so important. It's not only encouraging people to use better security and more affordable security, also improves Ethereum itself by doing so. And that's, in of itself, I think, one of the goals that we all want to have. Before I finish up, I want to give a quick alpha to what's going to happen with based applications and SSV kind of in the next few months. We realize that bootstrapping is not just about security, right? When you bootstrap a community, you bootstrap a validator set, you bootstrap a brand, you bootstrap recognition, you bootstrap a lot of different things. And we think there's a missing piece here because it's very hard to bootstrap. From the moment you announce to the moment you launch, something needs to happen in order to bootstrap. And it's very, very hard. And so if shared security ultimately as a goal is to facilitate easier and easier bootstrapping, something needs to be this connective tissue between developers, communities, and validators. And for that, we've come up with a scheme, I think, which is super interesting, called SSV tickets. Tickets are an actual token, ERC20 token, which serves as an access token for based applications. So in other words, if you are a staker, if you're a user, you want to participate in a based application, you have to have tickets. You can earn tickets in a bunch of different ways. It doesn't cost anything. But once you have those tickets, you can actually access and participate in various based applications. The cool part is, the more tickets you have, the more rewards you get. But the more tickets you use in a specific based application, the based application developer gets a bigger grant from the SSV DAO. So it's kind of this magic circle where, on the one hand, you can earn those tickets by performing a bunch of different things. For example, run a validator as a solo staker, you get tickets, you use those tickets in a based application, earn extra rewards, and you're encouraged to do so because of your participation, because you want to bootstrap ultimately as a project. But then the developer you're actually using their product is getting a grant from the SSV DAO. And so this kind of self-encouraging tokenization system will enable, in our opinion, to bootstrap from announcement all the way to mainnet, because all of a sudden there's this connective tissue between announcing, bootstrapping your brand, bootstrapping your community, all the way to actually launching your product. Think of it as kind of the next evolution of points, but with something substantial you can actually do and use. And that's, I think, the missing link. So if anyone is interested in learning more, definitely contact us, because we're rapidly developing based applications. So we've announced SSV 2.0, which is kind of the based applications protocol, just in end of January. We're already in DevNet. Next month, we're going to be in public testnet, offering a dedicated SDK, example projects, developer community, and so on and so forth. Mainnet in April and May. Super aggressive, but that's what we've been doing with SSV for the past 2 years. And so if anyone wants to kind of bootstrap their protocol, bootstrap a community, and specifically be based on L1 validators, definitely contact us. Thank you so much. I don't know if you have time for any questions. Anyone? Yep. Yeah. So those are really two good examples. By being based is really meaning that the functionality and security of a protocol is based on L1 validators. And it can be any type of protocol, any type of service that requires a validation or an operator set, right? It can be bridges and oracles, it can be AI agents, it can be ZK provers, it can be co-processors, it can be firewall, it can be a bunch of different things, a bunch of different use cases. The commonality between all of them is that ultimately they have an operator set, right? Somebody that needs to run their protocol. And so if you need somebody to run your protocol, what better validator set than Ethereum or Solana or Bitcoin, right?
In that case, how similar is it to
So there are definitely similarities. I think that there's a very different approach here for kind of the same goal, right? So shared security or bootstrap security is kind of the goal. While restaking is taking the capital route, basically saying, okay, put on capital in a smart contract, that capital is the bond for you to execute whatever you need in an honest way. We say that there's another approach to it, which is we already have those validator sets, which already are bonded, right? And so we want to reutilize that type of asset because this is the best validator set in the world. This is untapped asset, which costs much less. And so you can build your security on validator entities. Of course, if you need bond, you can add, but in a much smaller amounts. And so overall, the amount of security you get, the quality of security you get, the diversity of security you get is much similar to the L1s you're using than creating your own validator set. Oh yeah, if anyone has any other questions, definitely. Yep.
So if you're not putting capital at stake, then like how does slashing work if a validator doesn't perform the work they're supposed to perform?
Right. So when you're talking about security, there's really two parameters or really two properties you want, right? There's how much capital do you need to attack a certain protocol, and then if you do attack it, how much you stand to lose, right? And so what we're saying is that those two properties are kind of, complementary to one another, but you can use different assets for them. So for the cost to attack, like how much capital do I need to compromise, the best asset you can use is the actual validators from Ethereum, Solana, and Bitcoin, because you have plenty of them. You can enjoy the actual security properties from those validator sets. If you need cost of corruption, like if you need a cost if you actually attack, you can use bond in capital. The only question is how much. And so with kind of the restaking approach, everything is capital, right? You put in 100 ETH, that's 100 ETH worth of security. With based applications, you'll probably put much less than 100 ETH and join this other untapped asset called validators together to get much more security overall. And so it's really a question about what type of asset you're using for what purpose. It's not about not using capital, it's about how much capital do you need to use, because capital is super expensive, right? There's alternatives to putting 100 ETH in restaking. You can put it into Binance and you can put it into DeFi, you can put it into whatever you want. And so capital is expensive. Here we're using an untapped asset which has a lot of interesting properties for security.
How much you stand to lose. And in terms of how much you stand to lose, that would involve whatever third-party bond or out-of-protocol bond that validators have to do. But the core protocol itself, let's say the Ethereum Consensus Protocol or Solana Consensus Protocol, is oblivious to the existence of SSV in terms of its security parameters.
I don't know if oblivious I would use that word. Maybe conscious is a better word, but yeah. I get what you're saying. I get what you're saying.
Yeah, it's just knowing the spec. And so it's more like, yeah, we're trusting that validators will act honestly, and you kind of have like a two-faced problem. Like, yeah, I'm going to act honestly as an Ethereum validator, but for an SSV validator, it's like, oh, I had an opportunity to like really make $1 million here, and my risk was like losing $1,000 worth of like the bond. So there's that disconnect right then. That's the part which makes it a bit.
It's not a disconnect at all. So ultimately, the developer for based applications define what exactly the type of security they want, right? So I'll give you an example. Let's say you're a bridge, right? And that bridge needs to be super secure, but not only secure. If something happens, you need to compensate people, right? So that's type one of a based application. In that type of based application, you might want more validators and more capital. But there are other types of applications which, for example, a verifiable computation, which you can get it wrong, but ultimately you want statistically to get it right? You have 1,000 validators and you get some kind of a threshold, right? In that type of application, you might need much less capital because even if you cheat, the implications are not that big. So it's ultimately about configurability. What I'm saying is that if you take those two parameters, how much capital do you need to compromise, and then how much you stand to lose if you actually attack a protocol, it greatly changes between different types of services and protocols. The thing is that the validators themselves are around 90% cheaper than capital. And so if you combine the two, even at the worst case where you really need a lot of security, it's still going to cost you much less per TVL by using this type of asset rather than 100% capital, because you simply have more of that. So the example I'll give is, would you rather have 100 ETH worth of slashable capital and that's it, or you'll rather have 70 ETH worth of slashable capital, but 1,500 ETH of validators that provide Sybil resistance, right? And so, in my opinion, 1,500 ETH of Sybil resistance plus 70 ETH worth of slashable capital is much better in terms of security than just 100 ETH worth of slashable capital. It's just a matter of how difficult it is to attack your protocol, right? So it's the combination of the two. And so I think by introducing this new type of asset, you have that flexibility, and overall you'll have much cheaper security for the same amount of cost, even if you consider slashable capital and all of those types of things.
I don't want to hog the mic, but this it's like a whole dialectic, so I think it's best to, unless everyone's...
Yeah, you can go ahead.
Yeah, because the biggest issue is that this 1,500 worth of capital and everything on ETH, like the SSV doesn't have any control over it, doesn't have any regulation over it. You're pretty much hoping that these validators stay honest based on parameters.
No, it doesn't assume anything about the validators. It assumes that you pick a bunch of different validators, and there's some incentive for them to be honest or malicious, right? What I'm saying is that ultimately that decision is either if you put capital or not put capital, right? It's all about how difficult it is to attack your protocol, and then how much do you stand to gain or lose if you do that. What I'm saying is that even if you penalize me 100%, right, with my capital, which is kind of the most extreme capital-oriented security type, you still have this parameter of how difficult it is to even attack you. Right? So I'll give you an example. Ethereum is very, very hard to attack. It's not because of its slashable qualities, it's because of how much validators there are, and the Sybil resistance and the distribution of malicious versus honest validators, right? And so the property of how difficult it is to attack is as important as what do you stand to lose if you do attack. What I'm saying is that I'll give maybe a more physical example, right? Imagine you have a bank, right? And that bank has 2 armed guards, right? Or 3 armed guards. If you attack the bank and try to steal something, they'll probably shoot you, right? And so what you stand to lose is your life probability between 3 different armed guards. Now, you have the same other bank, and obviously you can corrupt those armed guards and so on and so forth. You have another bank which has a really, really, really big vault. But instead of 3 armed guards, they have 2 armed guards. Which bank is more secure? Well, the obvious answer is the one with the vault, because every bank has a vault. Right? Yeah, every bank has a vault. Because the vault is manufactured by a different entity, it's very hard to corrupt both vaults and armed guards, so it's a different type of security. In my opinion, a much better type of security, and much cheaper, because guards are expensive, they need to pay salaries, vaults are not as expensive. So it really depends on how do you fund security. Cost to attack the system is as important as cost of corruption, or what you stand to lose if you do attack it. And with restaking, it's all about what you stand to lose. What I'm saying is that we need to get the cost to attack much, much higher, use much less capital in order to penalize, because it's going to be much harder to even attack. That's why you're bootstrapping with existing validator sets, which are amazing. If you randomly pick, 10,000 validators from Ethereum, the Sybil resistance between them is quite good. Again, if you pick them randomly. By the way, that's what Ethereum does with the Bitcoin chain, right? Every time there's a block, there's a committee, you randomly pick about a few thousand validators and so on. So randomness with a very large validator set is very secure. And so it's all about those 2 parameters. What I'm saying, you can get much more of them for the same cost if you just combine a type of asset which is untapped right now.
I have to do some more reading on this, but I can't help but feel that I'm either relying on the reputation or the goodwill of existing validators who Ethereum respect. Like, my concept of security is more like, if I am not making the incentive provisions for it, then these actors are not acting in a way I can regulate, and they can still always go
But
rogue.
they do have a bond. They do stand something to lose.
Which is small compared to, like, you know.
Well, small is relative. Even if it's 25% less, you'll still get much more Sybil resistance, which is, by the way, one of the key parameters in security, because if you have a lot of TVL securing, even if all of it is slashable, but all of them are coordinated in attacking your protocol, then that's it, right? I mean, so Sybil resistance is major. Cost to attack is major. So you're compromising by using a very expensive asset. What I'm saying is you can lower that asset by 20, 25% and get 2 or 3x more TVL securing your protocol, so it's going to be 2 or 3x more difficult to attack it.
I need some time.
All right.
But I appreciate you. I really appreciate you. This is why we build this stuff, right? Yeah.
Perfect. Anyone else? Thank you, guys. Have a great week.